All right, we are back at CNBT 1311. This is the fourth video in chapter 11. Water supply system terminates at each plumbing fixture. After water has been drawn and used, it enters the sanitary drainage system. Okay, coming out of the spigot, this is potable water. As soon as it leaves the spigot, as soon as it clears that spigot, it is considered non-potable, and it must be treated. Doesn't matter what you did with it. It's non-potable or potable. And it goes to the sewer system. All right. So, and it's disposed of fluid waste and organic matter as quickly as possible. All right. Since sanitary drainage system relies on gravity for its discharge, its pipes are much larger than the water supply lines, and they've got to be on a slope. They have to be on a slope. Now, here are all kinds of elbows. This is a 90, that's a 45. A good plumber on a gravity sewer line is going to use two 45s to make a 90, so you don't have this sharp 90-degree turn. This is okay for pressure piping, all right? Not so okay for gravity flow lines, unless it's huge, unless it is huge. But the problem with a sharp 90 like this is, remember those flushable versus flowable wipes? They like to get hung up in here. All right, this is a drop elbow. It has lugs for attachment to a wall or joist. You'll see some of these for supply lines. They'll be nailed to the fixture header that feeds the shower or the bathtub. All right, you don't see too much of that for gravity. All right, again, gravity flow's got to be on a slope. Your licensed plumber who's gone through his apprenticeship and taken his state test can explain to you about the good, the bad, and the ugly of all these. These are T's, because it looks like a T. This is a sanitary T. Now we call this a sanitary T simply because it has a long slope coming down, okay? Long radius on that. Because if it's sanitary, it's going to be gravity flow. All right. This is called a Y because it looks like a Y. All right. For joining a branch pipe with a main, usually at a 45-degree angle. Depending on how small or how big these are, how small they are, sometimes getting a snake in here to clean the pipe or a camera can be problematic. These are more preferred for a clean out because you're going straight in at a 45 and you're not turning a 90 with the camera or the power snake, the rotary snake going down through the pipeline. All right. Sometimes you'll see these terminate outside where you'll have a straight clean out up here and then a Y. Why you would do that, I have no idea. But sometimes they do. These are couplings. They couple along our nipples. This is a nipple. It's a short piece of threaded pipe. If it's threaded piping, it's going to be MPT. In Nancy, Paul, Tom. National pipe thread. A national pipe thread. They have special dies to cut these because these threads are on a taper. This isn't a straight cut, single point cut like you would on a metal lathe. These national pipe threads or national pipe taper are have a tapered thread on them. Okay, they're tapered. And I've got a whole 5-gallon bucket of pipe threads, and threading tools that I've collected over the years out there for doing this. All right, this is an increaser. So it's smaller diameter on one end and a larger diameter on that end. You see this in pressure piping. This is really not for sanitary piping. These are pressure pipe. This is a coupling or a union, okay? The proper name in plumbing apprenticeship is it's a union. And you can use these for gas, natural gas. You can use them for water. It's a good way to connect two pipes, neither of which can be turned, consisting of two internally threaded end pieces. Gas unions, depending on the are a little different than a water union. Okay, gas unions will have a internal bolt in them. You lubricate that up good with plumber's grease and connect them. All right. And these are tightened on each end. You pull the pipes apart. They drop in. This collar then threads up and clamps it tight. Let's see. For gravity sewer patching, you can use an elastomeric coupling that has pipe clamps on both sides, and you can clamp two square ends of sewer pipe together. These are plugs. They'll plug the end of a pipe. Let's say you've got a deadhead reducer and you're not going to put anything on it. You can put a pipe plug in that one. These are pipe caps. They go over like a nipple, and it just closes off the pipe. I've got a whole box of these, so when I do plumbing work, I'm not relying on the valves to completely seal, because after long years of service, the valves sometimes don't seal while I'm working underneath the sink or something, so I'll cap them off. This is a bell and spigot. This is the bell. This is the spigot of the pipe. It come in all different shapes and sizes. I'm going to have, like this one here that I just messed up the drawing on. They'll have a little notch in here, cast in with the pipe, whether it's PVC or what, and that will push around the gasket, the ring gasket in here, if it's a elastomeric gasketed pipe, and seal. And this is gravity. Okay. Now they do make bell and spigot pressure rated pipe. But they tend to pull apart during the hot parts of the year, and some of your water mains have that problem. But this is a typical gravity flow. Bell and spigot pipe joints are made by fitting the end of a spigot of one pipe into the enlarged end, the bell of another pipe, and sealing with a caulking compound or a compressive ring. Belts and suspenders. In the ancient days of yore, you would take oakum. Oakum is organic, like grease or oil with hemp, and drive that oakum ring around here, and then you would pour lead in these things, lead oakum joint, and you would heat up that pot of lead and pour that in there, and that would be a leaded oakum joint pipe. I still think they require that on your plumbing test in the state of Texas. My first house with my first wife in Oak Forest, when I redid the kitchen in that one, seems like every wife I get, we end up redoing the kitchen. We had cast iron pipe coming out of the ground for the sewer, and we were bringing PVC in, and made up some oakum. Went down to the hardware store and got the oakum, drove that oakum in there, and then heated up wheel weights. Went to a tire shop, got a bunch of old wheel weights, melted it down, and then poured the molten lead in around the PVC pipe and the oakum to seal it, and it sealed it really, really good. But it wasn't Schedule 40 PVC, it was Schedule 80 heavy wall for that, and then I used and then I made it up the regular Schedule 40 PVC after the Schedule 80. And I was just lucky. My next door neighbor was also a licensed plumber, and he came over and we drank beer and remodeled the kitchen. He was a neat old dude. Anyhow, big old burly plumber. Now, we talked about pipes and walls, did we not? Yes, we did. Here's some rules of thumb for a 4-inch stud wall. Okay? For a 4-inch stud wall. Now, if this is a 2x4, we know that this is 3.5 inches, right? That's 3.5 inches. That's not 4. That's 3.5 inches. 3.5. 2x4 is 1.5 inches by 3.5, right? Okay. Theoretically, you can get a 3-inch hubless cast iron or plastic pipe, PVC pipe, in that wall. Theoretically. 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 If it's a bell and spigot, it can only be 2-inch. I don't know too many people that are using bell and spigot cast iron pipes anymore. Now, that brings us to a good point. What's the difference between cast iron pipe and ductile iron pipe? Well, they're both cast. You know, cast iron is more brittle than ductile iron, and ductile iron is stronger than cast iron pipe. But you can get cast iron pipe that's traditional cast iron, like a cast iron skillet, and not all cast iron skillets are the same. You can get porous cast iron skillet, or you can get the super duper cast iron stuff that we like to cook in at my house by Staub. It's a French company. Their cast iron is very dense, and it's got good coating on it. So not all cast iron is created equal. All right, those lathes and milling machines that I bought for the machine shop lab at the Cypress Center are melanite cast iron from Taiwan. And the reason I like that is because it's very, very dense cast iron. It's not some of that crap you get from China. Now, China can make some good cast iron, but you've got to spec it, and you've got to have your own inspectors over there to hold their feet to the fire. All right. Well, anyway, let's get back to the rodeo here. All right. For a 6-inch stud wall, you can put a 5-inch pipe if it's hubless or plastic pipe, or a 3-inch bell and spigot. And for an 8-inch stud wall, you can put a 6-inch hubless or plastic pipe or a 5-inch bell and spigot. So you got to be careful about what kind of soil pipe is coming down. Okay, if not, then you're going to have to build you a pilaster out here out of sheetrock just to hide the pipe. And in some cases they do that. In some cases for structural steel buildings, those for lack of a better word, those sheetrock gypsum board casings that you see abutting out of the walls to hide the columns. Inside there is not just the steel column, and this does provide fireproofing, but they'll run piping through there and electrical through there, and they'll run the ground wire out from the structural steel frame outside to the ground rods. So you may end up having to do this if you're not careful, and if it doesn't fit with the feng shui of your interior design, they may make fun of you at the office. All right. Okay, enough of that. Let's move on. Sanitary drainage systems are very similar to the pressure piping systems. If it's running, it's being driven by gravity. All right? It's being driven by gravity. All right? And just like in pressure pipe system, we have branch drains or branch supply pipings. You got horizontal drain lines. Um, you got soil stacks, which is a soil stack carries the discharge from water closets or urinals to the building drain or building sewer. That's the long drop. And depending on how far the drop is, you may have to put some energy dissipators in here. Because as this velocity increases in the drain from up here on the upper floors, it will have a tendency to pull a vacuum on these branches, and could actually start pulling the water out of your P-traps in your toilets and in your sinks. So you got to be careful with that. This goes back to your MEP people, your MEP engineers, your mechanical, electrical, and plumbing, right? Now, along with the soil stack, you also have to have a vent stack. And let's see, here he goes. Here's your vent stack. It's a vertical vent installed primarily to provide circulation of air to or from any part of the drainage system, so as this water is cascading down, it's not pulling a vacuum and pulling all these P-traps out. You'll notice that each one of these has a vent stack, because if not, you run the propensity of pulling a vacuum and pulling the water out of your P-trap. You don't want to do that. With the vent, that goes up to the roof. It allows us to have a free flow, a free gravity flow. All right. Minimum bends in all your stacks. Again, this goes back to the MEP people, and he throws a term in here called branch interval. It refers to a length of soil or waste stack corresponding to a story height, but never less than 8 feet, within which the horizontal branch drains from one floor are connected. All right. And then you're going to want a fresh air inlet down here at the bottom. This is like for a commercial building. All right. It's just a vent stack. It's just a fancy name for a vent stack for your main sewer that goes out to the sanitary sewer. Okay. And all of this is gravity fed. All right. So you've got to watch your slope. You've got minimum slopes and you got maximum slopes. If the slope is too great, then the toilet paper and those quote-unquote flushable wipes and the solids will start to the water will run ahead and leave the solids back in here, and you don't want that. All right, this is a clean out CO. I would not skimp on the number of clean outs. The worst thing you can do is have a sanitary sewer system without enough clean outs to get in here and rod this stuff out. Either jet it out. You also want to run cameras if you got a problem, because sometimes as ground settles, remember settlement, these pipes will settle. All right, as the ground either subsides or consolidates because they didn't backfill it properly, and you'll have a belly in this pipe, which means water that sort of maintains and stays in here and starts to decompose, and solids will drop out, and then your 8-inch line no longer is 8 inches. That was the reason we had to reroute the sewer in my 50-year-old house, because the sewer line going underneath the slab had a belly in it over the years. And I wasn't going to let them tunnel underneath that thin slab to redo that sewer line, because there's no way they could get that soil compacted. I don't care what they say. There ain't no way on God's green earth you're going to, it's just like we talked about underpinning before in slabs back many videos ago. There is no way you're going to completely consolidate that soil after tunneling underneath the slab or underpinning to 98% compaction. I don't care what they say. And then here's your building trap. That's a main trap. Sometimes these things are really huge. these are installed in the building drain to prevent the passage of sewer gases from the building sewer to the drain system of a building. Not all plumbing codes require a building trap. Not all codes do. Some do. You must check your building code. All right. It's just a giant P-trap for the whole building system. And you'll notice there's a clean out here. There's clean outs here. There's a clean out there. On each one of these floors up here. He doesn't show clean outs, but I guarantee you, if I'm inspecting these drawings as the lead engineer, there are going to be clean outs on each one of these floors. The last thing you want to do is have to pull a toilet or yank all this out to try to snake a clean out through there. You don't want to do that, especially in a high-rise building. Now let's talk about sump. Sump pump removes the accumulations of liquids from a sump pit. Well, okay, you got a sump pit, you got to have a sump pump. It's required for fixtures located below the street sewer. So let's say you had a deep basement, like in some of those downtown buildings in downtown Houston, and out off the Galleria area. Your sanitary sewer, which is gravity fed, and this is really a poor drawing. I'm sorry. I like Ching, but this is not how it's usually done. They don't come into the side of the bloody sewer. What they actually do, and since you're paying money for this course, and I'm an engineer, I'm going to show you really what the thing's going to look like. Here's the sewer, and then they'll have a drop stack that comes off the top, the socket. This is the flow line of a sewer pipe, or a pipe. The bottom is the flow line. The top is called the soffit, or a spring line. It's really a soffit, just like the soffit on a house. Okay? All right. That's the soffit. I'm not going to spell it all. That's the soffit. We'll see how many of y'all actually pay attention to these videos. And this is the flow line. Well, that's not an F. It's a flow line. Oh my God. Remember, I'm a professional. How about doing a real F? There we go. Flow line. And so this gravity line then will come down here on a slope, and it'll attach to this stack, this sewer stack, and then drop down in the top of this sewer. And but let's go back to where we were at with the sump. Sometimes the bottom of the building is lower than the elevation, the flow line of your sewer. Because remember, these are gravity fed too. So this line, this main sewer line, will travel X number of distance, and then it will drop into a lift station, which has submersible pumps in it. And then these pumps then will pump the sewage out of the lift station into another gravity sewer, and it'll carry on, and it'll be a series of lift stations all the way to the wastewater treatment plant. And the further it goes, the bigger these pipes get. I've engineered and designed some 12-foot diameter main sewer trunks, 2 of them coming out of the city of Houston to the 69th Street wastewater treatment plant. You can drive a truck through them. That was before the sewage got in them, of course. All right, so that's sump pump, okay? And sometimes in some remodeling jobs, if somebody in a basement, let's say you had a basement to a house, and you wanted to put an apartment down in your basement, you might have to cut a sump. So you could put a toilet in here, or a bathroom or something, and you got to size the sump and the float switches and everything else, then to lift all that up to the sewer, the house. All right, well, that's what a sump pump does. Okay, and as you can see, you got to clean out here, which is a nice run all the way down here, and we got to clean out there and clean out there. Do not skimp on clean outs. All right, we think we beat this up enough. Sewage disposal systems. Let's look at our time. Sewage disposal systems. All right. I think this thing runs to what? Yeah, we got electrical. All right. All right, sewage disposal systems. This is a whole course in civil engineering school, real school, 4 or 5 year programs. They're called environmental engineers, sewage treatment people, water treatment people. They have a master's degree that a lot of civil engineers will go get, called environmental engineering. You spend a lot of time studying water and wastewater treatment. Prior to the advent of regulatory laws for treating sewage, we had a lot of cholera outbreaks. It's because of the fecal bacteria from sewage going into the drinking water system, the creeks and rivers and such. So sanitary sewers usually convey sewage from plumbing fixtures to a public facility or treatment disposal. Okay. When this is not possible, like out in a rural area where you're not stuck, you don't have a mud district, and some mud districts, municipal utility districts, only supply potable water. They don't supply the sewage. Sewage treatment's extremely expensive. Lift stations are extremely expensive, and the minimum lift station used to cost $100,000, and that was the rule of thumb that we used to use. You start at $100,000, $100,000. For a little bit more, you can get a bigger lift station, but the break-even point to start with was about $100,000. But when it's not possible, a private sewage disposal system is required. Its type and size depend on the number of fixtures served and the permeability of the soil. Now, we talked about soil permeability back in the soils section in the early part of this course, and that is determined by what is called a percolation test. Now, sewage disposal systems are designed by sanitary engineers, civil engineers, and must be approved and inspected by the health department before being put into use. You need to consult the building code and health codes and the county codes and the state codes and every code known to man in your area before you go off and bite off into a private sewage treatment system. Now, there are many types of sewage treatment systems. There's a dry system called a Clevis Multrum, which you'll take your water from your bathtub, your washing machine, your kitchen sink, and the water from your kitchen sink will usually run through a grease trap, which will let the grease harden, and then that water is gray water in some areas. It's considered gray, not black, and then you can use that water to water your garden or your flower beds or whatever. Okay. Some areas, based on the code, the health department, they treat all that water as if it's black water. All right. But a Clevis Multrum system, your defecation and your urination is in the Clevis Multrum system only. There's no water in there other than your urination, and you don't dump the toilet paper in the Clevis Multrum or your wipes. They go in with they go to a side container, and then they're disposed of with the garbage. And the Clevis Multrum is a dry composting system. They've been around a long time. They come from Scandinavia, and you can get those commercially available, and they work real well in an elevated structure where the Clevis Multrum is either in the basement or on the ground floor, and all the living is on the second floor. And then When the lower level of the clevis multrum decomposes and turns into compost, then you can shovel it out. Sounds really cool, doesn't it? It's like shoveling out a horse stall. Um, all right, we go from the dry compost to what's called a septic system. Septic means it's a covered, watertight tank for receiving the discharge from your sewer, and it's separating out the solid organic matter, which is decomposed and purified by anaerobic bacteria. That means you're not introducing air. It's anaerobic, and allowing the clarified liquid to discharge for final disposal. Now herein comes the problem. Collecting the solids for an anaerobic deal is one thing. What are you going to do with the effluent? The effluent is a fancy word for the clarified water. Okay, doesn't mean you can drink it. It just means it doesn't have the solids in it. Okay. All right. Well, it's got to go out to a drain field, or it's got to go someplace. All right. Some codes will allow you to do certain things with that. Some will not. In some areas, they have outlawed septic tanks because of the density, the population density, and the area of which you have for a drain field. There are calculations that have to take place with your local health department to figure out, based on the percolation, and that's a fancy name for how water absorbent your soil is. You go do a percolation test. You'll drill a hole in the ground and put in a calibrated cylinder, and you fill it full of water, and you time to see how long it takes for that water to go down. And based on that calculation, you go back to the table, assuming the local ordinances will allow you to actually have a drain field and a septic tank. But these drain fields can be very large and cover a lot of area, and depending on how many fixture units you're dumping into this thing, will be the volume of water that's coming out. And some of these drain fields can be mushy. You don't want to drive on them. There's a whole design of how to do a drain field. He's got one over here where it's a 60-foot maximum distribution pipe should run perpendicular to the slope. Well, no kidding, because it's all gravity flow. All right. He's got a distribution box, and here's your septic tank, and here's your grease trap up here. Now let's talk about the darker side of midnight of these. Eventually that grease trap's going to get filled up. You got to bring a septic tank, a septic company out here to pump the grease trap out, or it'll start backing up into your house. So this is typically, if you're allowed to have a septic tank, your grease trap's first, it flows over here, it goes into the septic tank, and eventually these solids build up, and your septic system will not allow you to have as much flow through here. So you got to have them come out and pump the solids out. Pump all this out, get the solids out, and then take it to a wastewater treatment plant and dump it in their system so they can continue to treat it. What was anaerobic, most of your wastewater treatment plants now all have aerobic digesters. I don't know if any of them that are using anaerobic. The last anaerobic one I worked on was an old one out in Pasadena, and that got tore down when we remodeled the wastewater treatment plant and put in a pure aerobic system using pure oxygen and aerators to activate the bacteria to digest the sludge. Once that sludge is fully digested, it has to be dewatered either through centrifuges or a belt press, and then that sludge can be put in a sanitary landfill. They used to let them use it to fertilize hay fields, but I don't know if the health department allows them to do that anymore. The 69th Street sludge dewatering facility or furnaces, we used 30,000 RPM centrifuges to dewater that sludge, so it was like mud. and then that was conveyed into furnaces, and that sludge was dewatered, cooked. Um, all the pathogens were killed out of it, and into a powder. It smelled like pig manure, and pneumatically conveyed to storage silos. And then from the storage silos, then we transported that pneumatically to either rail cars, and then we had a barge loading facility where we'd fill up barges full of dried sewage sludge, and they'd take it off and try to sell it as fertilizer. Um, anyway, all the bad stuff was cooked out of it. The only downside to that is in a municipal treatment system, you get a lot of heavy metals, and that was a big concern back then, and it still is now, because people pour all kinds of stuff down the sewer. Anyway, that's an anaerobic. Means there's no oxygen in there. Okay, and the liquid effluent is about 70% purified, and I would not rely on that. I would not rely on the fact that Ching says it's 70% purified. Um, uh, now, so, but theoretically, if the anaerobic system's working right and you got your biological balance, and I don't know too many people that own these things that are environmental engineers and do a COD, which is chemical oxygen demand, and a BOD, a biological oxygen demand, and do the bug test balance on these things. This is like everything else. You flush a toilet and go do something else or forget about it. But anyway, let's just assume that it's 70% purified. Assume. All right. It can go to a drain field. It can go to a seep pit lined with a perforated masonry or concrete wall, sometimes used as a substitute for a drain field when the soil is absorbent and the highest level of water table is at least 2 feet below the bottom of the pit. It can go to a subsurface sand filter. Sand filters are used only where other systems are not feasible. All right. You got no control over what happens once it disappears down through all of this. All right. Now we talked about, I call the stuff coming out of your toilet black water. Now, I used the term gray water before. Gray water refers to the wastewater from sinks in baths, showers, and dishwashers and washing machines. And that can be treated and recycled for such uses as toilet flushing and irrigation. My grandmother had all her gray water running out to her big old garden. So she didn't have to worry about using her well water to water her garden. And I swear I think she could have taken an old cowboy boot and made it sprout. She had a green thumb. She was something else. But nowadays, with the bio-friendly detergents that we have, using gray water for that kind of stuff is not as bad as it used to be with some of the detergents that from yesteryear. But that is a possibility, assuming that your local health code and building codes will allow you to do that. Okay. Gray water systems should be used in conjunction with other water conservation strategies, such as specifying water efficient fixtures and capturing rainwater and surface runoff for cisterns. And all a cistern is a hole in the ground or a tank sitting off to the side that catches your rainwater. Use it for landscaping. But again, it depends on how bad your gray water is. Your water has to be analyzed. Absorption trenches. Here's a good detail of a drain field, assuming you've got the room and the percolation test that allow you to do that. All right. All right. They're 18 inches to 30 inches wide and 30 inches deep. That's assuming you've got the soil that you can actually dig down 30 inches. All right. You'll put soil back on top. These are perforated pipes, and they're set in a gravel gravel like a French drain. All right. If you're going to do this again, my advice is you wrap this with the geotechnical fabric all the way down this trench so that you don't lose your gravel and then your drain fill sinks. Okay, the geotechnical fabric will keep the gravel from mixing with the soil, because remember, this is all water, right? Okay. All right, and then it depends on where your water table is. And all this goes back to the local health code in your area and the building code and everything else. All right. So that's a septic system. There's another type of system that he doesn't have in here. And let me check the 5th edition and see if he's got it listed. And no, he does not. Maybe in a 6th edition. If it does, and one of y'all got a later edition, and it talks about an aerobic system, send me an email and tell me what edition it is. But an aerobic system is very similar to a septic tank, except it uses electricity and it pumps air through here. And what it's doing is it's trying to balance the biological oxygen demand and the chemical oxygen demand, the COD and the BOD, to get that bacteria working, the aerobic bacteria, to digest that sludge. And it will make the effluent a lot more pure. And so areas that will not allow you to have a septic tank because there's not room for a drain field, you can put in an aerobic system. Take the AN off of it, and it's an aerobic system. And then they will use this for irrigation in the yard. They'll have sprayers, like regular irrigation sprayers, landscapes. Man, I'm having a hard time talking. With the pop-up heads, they'll have an extra pump. They'll have a pump station over here, and be on a timer. And my son and daughter-in-law out in their place in Waller County, they've got an aerobic system. And it also has a backup drain field, but it's not a septic tank. It's an aerobic. So you're pumping air in here. You're not using oxygen like we do in the big wastewater treatment plants. We turn these giant concrete tanks into pressure vessels with a couple of inches of pressure with pure oxygen and mixers to mix all that. You're just using air, atmospheric air. So you're balancing the BOD, biological oxygen demand. I keep throwing that out there. I probably ought to type that in here for this video. It's BOD and COD. All right. Now in the police world, COD is the cause of death, but in environmental engineering, it's chemical oxygen demand. Okay, it's the chemical oxygen demand between the bacterial wall cells, and then the biological is what the bugs want to live on. Okay. All right. Now we get electric power. Where are we at on this? It's 43. Let's go ahead and kill this one here. That wasn't very nice. Kill it. That sounds very bad, doesn't it? All right, we'll stop it here, and carry on with the next video. All right. Okay. I think this is video 5 coming up, isn't it? Yeah, video 5. All right.